So thank you so much for everybody who are joining us today. We're so excited to run our first Explore session. AI for Earth is the theme this lunchtime. So I'll just open up this space with the karakia. Ko te kawa o runga, ko te kawa o raro, ko te kawa ora, ko te kawa ora. E rongo e whakairihia ki runga, turuturu o whiti, whakamaua, kia tina, humiye, huye, tai kie. Kia ora, everybody. So, ko maheshi toku ingoa, no Sri Lanka o Kutipuna, ko te noho au ki te Terikingi. I'm the Community Impact Lead at academyEX, and my job is all about sparking connections, creating those aha moments, and building a vibe that makes everyone feel right at home here at academyEX. I'm the go-to person when it comes to making our community spaces buzz with engagement and interaction. So I really appreciate you being here with us today. If you're new around here, a big welcome to academyEX. Consider us as your learning buddy for your journey ahead. We're not just another tertiary education provider. We're the people who believe in shaping tomorrow through learning today. We're focused on all our learners gaining an edge in your career and staying ahead of the curve. Our courses are packed full of innovative thoughts, futuristic insights, and a bunch of stuff that matters right now. We're all about equipping you with the right tools, so you're not just making strides in your career, but also making a difference in the awesome world of ours. So check us out at academyEX if you're not familiar. So these Explore and Experience sessions are part of a new approach where we, listening to our audiences, we understand the need to go deeper and have deeper conversations. So this is exactly what we are going to put on today with our panel of experts, delving into a specific topic from multiple perspectives. This will then link on to an experience challenge in May, where we'll go even deeper, but get experiential and connect as a community on site at academyEX. So we're going to use the learnings that we learn at the Explore sessions and then use that in our experience challenges. So please check out our experience challenge that's scheduled for May. Some Zoom room rules. Please use the chat to ask questions for the panel. So I'll keep an eye out for any questions that come through. Keep yourself on mute. We are recording this session and we'll distribute the recording for those who participated and who couldn't make it today. We're also using a tool called TLDV to capture notes so we can recap the session for you. Agenda, you'll hear from our panelists very shortly. They'll introduce themselves and explain about the cool things that they're doing in the subject area. We'll also open up the floor for panel questions, and we have some pre-prepared questions for the panel as well that they'll be answering. And then we'll thank you and wrap up by 2 p.m. Cool, so let's just get into the session. So today's topic, we often chat about AI, right? So because it's all around us now. Well, nowadays, we're not only discussing how cool it is or if it's being fair and respectful. Instead, we're asking, hey, can AI actually help us live more sustainably? Sounds a bit wild, but how can a bunch of code care about the environment, right? But here's the twist. We're now researching how green this tech can be and how it can help us to reach our planet-friendly goals. It's no coincidence we're discussing this in April, the same month we're having Earth Day. I mean, what better time to explore how our tech could help save the very planet we celebrate? So let's figure this out together, not just because it's Earth Day on the 22nd, but because every decision, big or small, counts towards the kind of world we're creating. So let's dive in. So I would love to introduce you to our panelists today. First up, we've got Kriv Naker, founder and managing director at Synaptic. He's also the board member and chair of NZ IoT Alliance and the innovation advisor at academyEX. We then have Professor Yan-Sing Ko, who is a professor at University of Auckland and the director of the Centre of Machine Learning for Good. We then have Josh Dry, who's the director of business development at Kogo. And then we have Tracy McCartney, who's the group planning manager at Ryman Healthcare and a master's candidate at academyEX. Her project is very relevant to this topic. So thank you, Tracy, for joining us too. A big thank you to our panel for being here with us today, and I'll hand over to Kriv to kick us off.
Kia ora all, and thanks Maheshi and academyEX for having me today. As Maheshi mentioned, the prevalence and relevance of AI in our daily lives across our personal, professional lives is ever present. And one of the areas that I follow as the founder and chair of the New Zealand Internet of Things Alliance, based on sensor networks and all things sensor data, as well as the work I do at Synaptech around having a look at the interface and the impact of emerging disruptive exponential technologies across our lives, really lends to this topic of how AI is having an impact on the earth, people, and everything around us. So over the next few minutes, I just want to touch on this emerging area of the artificial intelligence of things and the interface and engagement interaction between AI and IoT. So some of you who would have attended my lectures or talks in the past would see this diagram, but in the context of AI for Earth and in the context of utilizing data to train our new AI models, this becomes really relevant. AI has a crucial role in terms of the contextual awareness of these new AI systems, particularly when it comes to our natural world, when it comes to resources that we utilize from Earth, and again, going beyond as well in terms of things below the ground in our oceans, all around us, and increasingly into the airspace that we are innovating in as well. So from this particular circular diagram, the area here around the impact of the Internet of Things is using sensors and using sensor collection systems from a data perspective to drive new training models into AI. And one of the key aspects here in terms of understanding the impact of all of this new data on our new AI systems, particularly these new large language models that OpenAI are using to drive things like their ChatGPT interface, is contextual around where is that data coming from that is training these new LLMs. And particularly when we're making decisions around environmental, earth, sustainability considerations, and if we are using AI to help make determinations, help make decisions around what's good for people, place, and planet, then we have to question what type of sensory data inputs are being used to drive the training of those AI models. So if we have a look at just where IoT overlays in terms of this AI input system, when we gather data, process, analyze it, and that action, as an input into the training of these new AI models and training of these new AI systems, what earth data, what environmental data, what situational context data in the natural world is being collected? Is it being collected in real time? And then are we training these new models beyond, if I'm using OpenAI as an example, beyond ChatGPT 5, from a multimodal context? Then what are we doing in terms of the types of data we're collecting at an IoT and sensor level? And how are we training these new AI models? And what sort of contextual outcomes based on real-time sensory inputs are we deriving and expecting from AI going forward? So when it comes to, again, that multimodality or the multimodal inputs into these new AI systems, again, IoT has a huge role here in terms of how their data is collected, but also the integrity of their data. And what I've got on this chart here is just some of the data that's now being collected from a multimodal interface perspective as we train these new AI models, as we train the LLMs and build these new sort of GPT and other LLM interface AI engagement tools. So we're not just going to see just plain text or just audio. We're seeing a lot of other multimodal, and IoT sensor data will continue to contribute to that multimodality in terms of inputs that we use to train our models on. But where I want to leave you today, just as a as a capture of how we look at the impact, is something that the European Commission put up a few years back. And this is around the frameworks, around the collection of that data, around the input into the training of these AI models. The European Commission put this together from an IoT lens, but I'm looking at this now as this data that's collected. How is it being validated? How is it being integrity checked against the input training mechanisms used for AI models? So a few things to consider as we consider and talk today: trust frameworks, security frameworks around their data, privacy frameworks, engagement frameworks, and as you can see here on this slide, some of the considerations around accessibility, sustainability, ethics, liability, societal change, societal cycle, all of these elements from an AI for Earth and AI for Good and AI impact perspective needs to be considered. And if I'm looking at it from an IoT input lens or from an IoT data or sensor input lens, then these are core decisions that we need to consider in terms of how our AI systems are being trained for future decision making. So I'll leave it there, and I look forward to the panel discussion and some questions later on. Thanks.
Fantastic. Thank you, Kriv. And over to you, Yun.
Kira kata, ko Yun Seng ko toko inwa. So my name is Yun Seng, and I'm from the School of Computer Science. As Mahishi sort of pointed out, I'm also the director of the Center of Machine Learning for Social Good here within the university as well. So I've got two other co-directors, which is Dr. Daniel Wilson and also Professor Jill Dobie for this particular center. So I'll just give you a bit of background in terms of what our center does. So the mission of the center is to advance fundamental knowledge in machine learning and data analytics while addressing some of the challenging works or challenging issues that we're facing today from different perspectives, from health, environment to societal problems. So this is the first center in Aotearoa focusing on social good using machine learning in collaboration with domain experts. And it is we set up with a mission to be a catalyst to solve high-impact society issues with what we call bespoke machine learning techniques that we can actually build. So part of this center, we understand that machine learning is not a silver bullet, but tackling these problems requires a concerted transdisciplinary effort from all sectors, from onset of the project. So in terms of what we want this center to do is this center is a catalyst for new collaboration and feeds into university, nonprofits, government, non-governmental organizations, and our community. This requires us to have a deep understanding of what we are actually currently capable of doing, and what are the different types of domains that we're actually be using our techniques on, and what are, in particular, we're very concerned about the ethical and cultural safety as well. So in this talk, I'm going to quickly go through a couple of projects that we've gotten through this year. This is just a snapshot of our year. These are projects that we mounted in this particular year. So we've got a range of projects that we've actually mounted. And from this particular set of projects, the ones I'm going to focus on today is the environmental pathways or environmental sections. Most of these projects are available on our website. If you're interested, you can go out there and have a look. But the ones that are particularly interesting in terms of environment, I'm going to talk about two things today. One is air quality, and the other one is from a water quality perspective. So in terms of air quality monitoring, so what we have in terms of air quality monitoring, this particular project was in collaboration with NIWA, and what they were interested is looking at pollution from wood burners, which have serious health implications for residents. And in particular, what we were interested in looking at were the level of airborne particulate matters that often requires making inference about missing values from low-cost sensors. Now, in terms of why we care about this, is these particulate matters are actually quite detrimental to human health, because part of these particulate matters cannot be expelled from our lungs if it's small enough. So we needed to actually make sure that the level of quality of health or air quality that we have is sustainable for what we need it to be at. So in terms of what we've done is we've actually looked at all these. NIWA has gone up with a pilot study across several rural towns in South Island. And what we were given is a stream of observations from these sensors. These are low-cost sensors, which means that anybody can buy one off the shelf, put them up, and actually analyze it. But in particular, we had a network of these that we wanted to actually look at. So one thing that's actually quite interesting with these kind of sensors is they've got a couple of things. One is there is a lot of missing values. The variability of the data can change over time, which means the distribution of the data can change over time. If you're looking at these kind of sensors, the other thing that might happen is it needs regular calibrations, because these sensors can what we call drift over time. So it means that the accuracy of the sensor readings deteriorate somewhat. So there's a couple of cool things that they do at NIWA, which is they do some sort of calibration where they sort of take all these low-cost sensors and they sort of align them up with a bigger sensor. And you can see on the top right-hand side, they've got all these little sensors that's actually lined up with a bigger sensor that's more accurate. And the sensor has a power supply going into it. And they have that period where they put it in with the sensor and they sort of figure out what the readings are, and then they deploy it onto different spatial, different geolocations on a map. And then after the pilot study, they bringing those sensors back in and they co-locate again. So what it allows us to actually look at is that there's two things that we're getting from this. One is we're getting a sequence of low-cost sensors, a lot of data that's coming in that's actually across geospatial locations and temporal as well. But what we really want to know is beyond just predicting what the air quality will look like for a specific location. We wanted to know whether it is transferable once we learn that particular model. So from one of the projects that my students they're doing is they're looking at the adaptability of air quality model that's built on a particular town, and to see whether it's adaptable to another town. So we can see that if we transferred from Invercargill to Cromwell, what the model would look like over time. So the one in red is if we've transferred it, of course, higher, the value is better. And to see whether it actually works. Sometimes it's adaptable, sometimes it's not adaptable. But we know in advance whether model we can actually use a model for another town. So that's one project that we're working on. And the second project that we're working on is in collaboration with Waikato and Zera, and this is part of a tie-out program. This is another project that we're looking at the moment. And from this particular project, what we're looking at is there's many lakes in New Zealand and actually part of the world as well that's actually covered with what we call harmful algae blooms, where there's a rapid buildup of algae mass, which becomes toxic in the local ecosystems. So it can be detrimental to human health, and definitely sometimes it is actually detrimental to livestock as well. So to actually get some of these water qualities, typically it involves freshwater scientists go out, they collect a lab sample, and then they sort of analyze it. But these are actually quite difficult because it requires a lot of manpower. So instead, what we've decided to do is merge the small sample of data that the freshwater scientists have collected, and we use satellite data to actually together with these this particular information to actually look at it. So just so that we're looking at what we're typically doing is we're trying to actually figure out whether we can deal with these algal blooms in a very quick and cost-effective way, or a more sustainable way. So this is just a little example of how it looks like. This is algae blooms that you can see. These are green little parts. And what we're trying to do is trying to combine the satellite to actually figure out what the water quality looks like. And satellite imagery is cheap because it goes through, you have 1 or 2 snapshots in a day, and that's actually quite easy to compare. So one of the things that we did actually analyze is Lake Waikare, that's actually south of Auckland, and we looked at the water quality in that particular lake in December 2019, actually. So that's just generally 2 case studies from our center. There's lots of other projects that we work on. And part of the center is funded by Tayao. So if you go to tayao.ai, it is a big project that's funded by NBIE for 7 years. And we've got researchers this is led out of Waikato. There is researchers from Victoria, Christchurch, Auckland. We've got researchers from different CRIs as well. So that is me. Thank you so much.
Awesome. Thank you so much, Yun. Over to you, Josh.
Thank you, Maheshi. Yeah, kia ora koutou. Hello, everyone. My name is Josh. I'm the Business Development Director at a climate fintech called Kogo. We are on a mission to empower millions of individuals and businesses to reduce their impact on the environment, on people and planet. And we do this by enriching transactional data with carbon data to show them their personal or business carbon footprint, and then we take them on a reduction journey. So we've been around actually for 13 years. We were conscious consumers. We've been supporting individuals to align their spending with their values for a long time, and like any tech startup, we've gone through a number of pivots, and we've sort of found our niche with carbon tracking. And so we work with now 20 banks globally. I look after Asia Pacific, notably on this part of the world, Westpac, Suncorp, Commonwealth Bank in Australia, working with Kiwi Bank so far in New Zealand. So yeah, some really great names there that you'll recognise, and also partners. So it's really important for us to be very partnership oriented. We say that climate action is a team sport. So we work with a range of different partners. You'll know a bunch of those. AWS and Xero obviously stand out. It's really important for us to access data, but also to build experiences inside banking and accounting experiences. So that's sort of a bit of an overview of who we work with. And then what we do, well, we build carbon trackers, carbon calculators, carbon insights solutions into these core banking experiences. So we have 100 million individuals that have the ability to access their personal carbon footprint through the solutions that Kogo has built. And yeah, no mean feat for a small tech company in New Zealand. Maheshi, questioned me on what excites me in this area, and why do why do I get out of bed in the morning? And it's to do this. It's to empower individuals to have access to their data and to be able to use it for ways that they want to, such as seeing their personal carbon footprint and their impact on the planet. Here's some live examples. Some of those are moving quite quickly. The one in the middle is Westpac Australia. If you just want to focus there, you can see that we enrich their transaction data and show them what their emissions equivalent is. And that's a breakdown on categories and also by months as well. So that is, my sort of core role, and what excites me about what we do is to empower individuals to lessen their impact on the planet through these solutions. And our approach focuses on these 3 core areas. The first is measurement. Then we motivate those individuals or business owners. Then we mobilize them to decarbonize. And I'll touch on these 3 areas very quickly now, but later on in the discussion, hopefully we can dive in a bit deeper. The first piece is measurement. So there's an age-old adage, what gets measured gets managed. You can't manage what you don't know the number for, what you can't measure. And so it's really important for us to access this data and to enrich it with very credible market-specific emissions factors to show an individual or a business that number. And AI, which I'll touch on, can really help us streamline that, make it very fast and very efficient as well. The second piece is motivation. So how do we motivate these individuals and these business owners once they've got a number to take action? And yeah, some forms of machine learning have been around in a long time in regards to sort of retail and marketplaces and online purchases. And unfortunately, they've been responsible for some of the hyper-consumerism and overconsumption that we see. And that is a cause. It is called out in sort of, that ICS reports in regards to why we are in this crisis that we find ourselves. So motivating individuals and business owners to take action in the right ways is a big part of what we do. And again, we're using a range of tools to help us achieve that, and AI is one of those. And then the last step is mobilizing. So once you've got them ready to go, they're ready to take action. Well, how do you actually support them with that decarbonisation? And is it through funding from the banks, or is it from solutions that are close and near and suitable to the environment, to the systems which they reside? So here's a very quick overview of measurements. Look, I've touched on personal carbon management so far, but Kogo also provides business carbon management. So this is a tool that is live in Xero right now. If you're a small business owner, the tool is free. You can go into Xero in the marketplace and search for Kogo. You can utilize our tool for free to see your business carbon footprint. So that measurement is really crucial. And what's going to be really helpful to us is that the categorization of these transactions. So to know that you have, spend with Meridian Energy and that is classified as electricity, that needs to get categorized so that we can provide the most accurate emissions factor for that spend. And with machine learning, we have the ability to auto-categorize. So what that means is that an individual connects the Xero account, we auto-categorize every single one of their transactions into the right category, and we provide the right emissions factor to that category of business. Pharmacy, shoe store, petrol station, flight, taxi, whatever it may be. And so that's auto-categorization, and that's what's going to really supercharge our product to make the measurement very, very fast. The next step is motivation. There's a link here, unclickable right now. We may send our slides on afterwards, but if you just go to Kogo's website, you'll see our 5 guiding principles to behavioral science. Changing behavior is so crucial. As I mentioned, we're not just a tech company or a data company, but we're driven by changing behavior. And there's sort of 5 examples that we include in all of our solutions. And 2 I'll touch on that I think AI has an opportunity to help us advance. One is the personalization of that experience. So what we can do is we can look at others that look like an individual and surface an experience that we know would help them change their behavior. For example, if I'm driven by cash rewards, or if I'm driven by lessening my impact in a certain way, maybe it's electricity spend is really high, we can personalize that experience to help me drive down. Maybe that the machine is learning that I'm within a certain salary bracket or a certain region of the country, and these are some experiences that have helped others change as well. The other piece is nudging users. So nudging, think of notifications. They could be time-based. They could be spend invoice-based if you're paying someone at the same time, or you go shopping online at the same time. There's a range of personalized nudges that can pop up as well. And so again, it's about using the information that we've seen through collecting data on a lot of experiences to help guide those behaviors, to help others change theirs as well. So that's the motivation piece. And then the last is mobilization. Just going to go back one slide. There we go. It is mobilization. So, Kogo has a climate action recommendation engine. So here's an example of some of the climate actions that we have within our solution. I'll call out 2 there. One is switching to EVs, one's installing solar panels. So you would have seen in Aotearoa, there's a huge number of ads, both billboards and television, of banks providing sustainable or green loans to help businesses or households decarbonize. And so that is the mobilization we're talking to, is how can we then provide the lending, but also the sustainable solutions to these individuals to change their households or their businesses, switching them to electric vehicles, switching their fleet to electric vehicles. That takes a lot of funding. The numbers show that, there's an upfront cost. So if you can cover that, then over the course of the years, it pays back. The same thing with solar. New Zealand has a significant opportunity to electrify the country. And so by our makeup of our grid, by moving people to these home energy efficiencies such as solar, such as batteries, induction, insulation, all these sorts of things are really going to help not only that household, but the country. And so we just need to help mobilize with funding and solutions to do that. But yeah, hopefully we'll touch on that a bit further in the conversation. But yeah, thank you very much for your time.
Awesome. Thank you, Josh. Over to you, Tracy.
Thank you. Thanks, Maheshi. Thanks, Josh. So following on a bit from what Josh has been talking about, kind of similar area. So my role, currently I'm the Group Planning Manager at Ryman Healthcare. So we build and we run retirement villages in New Zealand and Australia. And back in 2022, we released a sustainability strategy, which got me looking at the construction side of the business to try and understand really our impact on the planet. And I realized that one of the areas that we weren't looking at was embodied carbon, which I'll explain a little bit more about. So that led me to academyEX to try and learn a bit more about innovation and also sustainability, both working together. So I'm currently doing the Masters of Tech Futures, and my topic is the measurement of embodied carbon in New Zealand's construction industry using emerging disruptive technology. Skip forward, sorry. So embodied carbon is the carbon dioxide emissions associated with the materials and the construction processes throughout the whole life cycle of a building or infrastructure. So we've got embodied carbon is within everything from the raw extraction of the material to make something all the way to the actual construction taking place. And then after that, we have the operational carbon, which we're all familiar with electricity, gas, and so on. I guess the important thing is that the building environment accounts for around about 39% of total global emissions. So a very, very large impact, and around about 20% of that is embodied carbon. So the actual material, such as concrete and steel and aluminium and glass, they account for the majority of the embodied carbon and therefore the impact on the planet. So I decided to concentrate on embodied carbon, and I'm now in the final phase of the Masters, which has been absolutely excellent. And I think my take really, having gone through this Masters and really getting to grips with both AI and sustainability within the built environment, my take on it really is going from the left-hand side, multiple data sources are what AI can handle. So it's really the AI can use lots of data sources which human beings cannot use quite as much. And that coupled with the requirements from a human point of view, i.e., as Kriv mentioned, training the model in the way that we want it to be trained. So with requirements such as having planet-friendly materials and ethical suppliers and so on, being able to train the AI in both those things and adding lots of data. I believe the AI could help in the sense of helping the planet to be a recommender system. So recommending humans based on multiple data sources and volume of data, becoming a recommender to humans to choose the best materials for construction and also create the best designs in order to help the planet really, and to help construction industry to use better materials, more ethical materials, lower carbon materials in the construction of the building. So rather than necessarily looking at operating carbon as emissions from electricity and gas after it's actually been built, taking that before the built, It's actually been built, and having an understanding of what the carbon will be when it's in its built form. So avoiding retrofitting later on down the line. Looking forward to the questions, and thanks everyone.
Awesome, thank you. So we just move on to our session where we ask some pre-prepared questions to the panel. So I'm just gonna spotlight everybody. But for that, so you have all their faces. Here we go. So the first question that we had was, what is sustainable AI? How do you make the distinction between AI for sustainability versus the sustainability of AI? Would like to go first? Good.
I'm happy to take that first, Maheshi. I think from my perspective, as we talked about data inputs and the insights that AI can generate, I think there's no dispute that the level and granularity of insights that we can generate around sustainability metrics and measures from AI is immeasurable. It's, as Professor Yunsing said, the more sensor data, the more granular we get with the data that we use to input into these systems, the better outcomes we can make from environmental sustainability perspective. So AI for sustainability, absolutely huge tick in terms of the potential impact that we can derive from insight-driven decision-making. Versus sustainability of AI, this is an area that I've talked about a lot and we discuss around the impact from the infrastructure that's driving AI. And one of the largest infrastructure elements is compute power. Generative AI in particular is using a huge amount of compute power, which uses a huge amount of energy resources. We're seeing that in the amount of data centers that are popping up all over the planet and here in New Zealand as well. We're seeing it in the amount of energy resource required to power those data centers. And if we continue on this trajectory of processing and compute power to develop further and further AI model generation and AI model processing and compute power, then it's going to put a huge amount of pressure on the sustainability of our resources from an energy perspective. So on one hand, extremely beneficial in terms of the insight outcomes that we can use to make decisions on what's good for our planet around sustainability. But on the other side, what's the potential hurdles that we're introducing by driving more compute power, using more energy resources as we strive for more and more AI-based compute platforms.
Awesome, thanks, Kriv. And throwing that question to you, Yun, you mentioned the myriad of projects that your students undertake. Is this a consideration that they embed when they're designing their research programs?
Yeah, that's a very interesting question. So in terms of AI for sustainability, definitely that's something that we sort of think about from day to day. And we always, from an environmental point of view, we sort of think, what are challenging problems out there and how can we actually make it better using ML or AI? So anything from environmental monitoring that I talked about to understanding how to develop renewable energy sources as well. On the other side of the coin, as Kriv pointed out, there is a lot of resources that's required, and it does actually lead to some environmental impact in terms of what are the power that's required to build these kind of machine learning models, what is required from all of those. So there is a balancing between benefits and risk. From our center's point of view, there's a couple of things we think about as well in terms of when we develop these models. I always tell my students, if you're going to do this, make sure the outcomes that you're thinking that you're going to achieve is going to be better than what resources you're taking up, basically. So one of the things I always quote is that I think the World Economic Forum said that if AI if left unguided, AI has the capability to accelerate the environment's degradation, and that just is counterintuitive to what we're trying to achieve. So there are a couple of things we talk about. One of the things I always tell students is that, yes, if we think about, and this is, if I'm not mistaken, when some studies have shown that Google's AlphaZero had created about 96 tons of CO2 over 40 days of training. That's kind of like 1,000 hours of air travel. But on the other side of the coin, what did Google AlphaZero provide us or leverage us in terms of being able to actually, what can we do now? So AlphaGo Zero is a precursor to a lot of other advancement like AlphaFold, that was a protein sequence algorithm that allowed us to actually sequence protein, and that's faster than anything that we've ever seen now. And there is sort of a give and take between that. So when we talk about all of this, I think we have to talk about it all in a collection. It's not one or the other, but both together. What does it really mean? So hopefully that sort of answers your question.
Thanks, Yun. Josh?
Yeah, I completely echo what Yun's just said, and obviously what Kriv started off. I think I just wanted to mention in regards to, yeah, that net positive impact curve, right? Making sure that the reason the use for AI is exceeding that of the environmental cost. And when you measure that impact, we're talking slightly environmental right now, but there's obviously many other reasons for environmental. I mean, you take Yun's example there of the rivers, clean rivers. Obviously, that's an environmental thing, but you know, I want to swim in our rivers, and that's a health issue as well, right? That's a social issue. So I think the impact of doing some of these things can be measured in a number of ways. But yeah, I think that's what's really important when you're looking at the data usage and subsequent environmental costs of AI is your net positive impact that you're using it for outweighing that. So I think that's the calculation that any startup, any project needs to measure.
Awesome, thank you. We also have a question from the audience related to this, from Chris Thurston. Is there a one-to-one relationship between the processing of more data and the storage requirements? Is AI machine learning also working on making itself more efficient to compute all of the masses of data?
Yeah, thanks, Chris. Really interesting question. I was just typing a response as Mahesh read it out as well. Currently, about 70% of data center costs are involved in powering the data centers, around energy and power. And as we drive, particularly with new AI needing more processing and compute power with multimodalities and more inputs, then we're going to see that energy requirement increase. You know, we don't want to get to full supercomputer capacity where we need a huge amount of power. So there are initiatives around the greenness of storage, the greenness of that compute power, how we can minimize it using smarter algorithms, but also having a look at how to power these data centers going forward. We cannot just continue to use a heavy carbon footprint to power our data centers and drive more compute power. We have to be more sustainable around the greenness of our storage and compute power.
Josh, did you want to add to that?
Yeah. So I did just want to add to that. So Kogo is a company. We measure and report. We have a reduction target, and then we offset our emissions. So we're certified net zero through the Toitu program. I just wanted to call out some work. So there's a gentleman called Hugh Walcott. He does a program called Silver Lining, and he's got some articles on that. Otherwise, I'll just drop a link into the chat for those interested. It's a Google Drive link. If it's not accessible, just email me or get in touch and I'll flick that through to you. It's basically the work Chris and others interested that Kogo did to actually measure the server amount that we actually use in processing our data and what we can do with AWS to reduce that as well. So it's called Digital Carbon Emissions Inventory Report. And so we went through that process with Silver Lining and Hue to ensure that we were measuring all of the emissions associated with our data as well. And there's a lot of, we did that in collaboration with them and AWS. So there's a lot of tools out there that can actually help with that. And we definitely encourage through our tools when there's a tech company that has a significant amount of data, and you can obviously see that in their footprint, that we encourage them to adopt these sort of solutions to start measuring and reducing, their data services as well. So yeah, big opportunity there to reduce the footprint of the technology industry as well.
Yeah.
Yeah, so I don't know whether you guys have heard about the 4 M's in terms of looking at carbon footprint. So I wanted to actually sort of talk a little bit about it. The first M is the model, as pointed out. Are we making models more efficient? And the answer there is yes, definitely. There's green AI, and what we do is trying to actually figure out what is the best way to actually train models. How do we do it more efficiently? Efficiency is one of the things that we're very center and as a research problem that we're all trying to deal with. The second M is machine. What's the hardware we're using? The third one is the mechanism. Where is the data center housed? And the fourth is map, which is like where's the geographic location of the data center and how green it is. So those are 4 M. And first M is definitely the model. How are we actually looking at building more efficient models?
Awesome. Thank you, Ian. It's a really good structure to follow. All right, might just move on to our next question. If you were to imagine a future where AI is a major force for good in sustainability, what would need to happen now to make this a reality? Wants to take Josh?
Yeah, I'll jump in first. I think I'll speak specifically to the sector that I work, which is banking and finance. And I think, right now we're trying to decarbonize the global economy. And there are many people and governments and organizations on that journey. We need about $100 trillion US to decarbonize the global economy to net zero by 2050. And that is about, $3 trillion additional each year on sort of assets to help spending each year to do that. And so it's a significant amount of money. And so I think to ensure that AI is being used in these ways to decarbonize, what needs to happen now is banking and finance industries and governments really need to get behind the use of this. And I think, we're looking at open banking, which should have been rolled out in New Zealand for many moons ago, and we're still waiting for probably middle of next year. So there's a lot of things that are holding back the access to data. If we had access to data and people could very simply share their data with the companies like ourselves to actually enrich and show them things that they want to see, such as their impact on the environment, then we can definitely move this along a lot faster. So I think, specifically to us, what I would like to see is big industries, especially in banking and finance, understand the decarbonisation opportunity. And it's not just about saving emissions and saving lives. If that isn't enough for some, it's actually a significant commercial opportunity to make money. The governments, the banks out there, if they understand, if you clip the ticket on $100 trillion, you're going to be making a lot of money. So I think that is what needs to happen, is that specifically in this area, which we work in, is that the realization of the commercial opportunity and also getting legislation out to empower the readily available access to things such as this would be hugely helpful.
And thank you, Josh. And in my chats to both Tracy and Yun prior to this session, I think we delved a bit into this. And I think your perspectives were on the AI models itself. Like, what are those kind of positive biases that we can build in? What can we do now to kind of, showcase that AI can be a major force for good. So did you want to comment on that?
Yeah, I'm happy to comment. So I do think this comes back to the training that we do. So rather than AI having a control of us having a control while we can, of what we want out of AI and having a kind of positive influence on what we want to achieve. So obviously we've got the Paris Agreement, the SDGs. We know what we need to do to keep the planet to 1.5 degrees. And really for me, it's about getting the controls, the ethics right from the start. And I think around the world, people are working on this, and that gives me hope that, we can have that control over AI and not let it kind of run away and negatively influence, I guess, human beings.
Awesome. Thanks, Tracy. Great.
If I can just add to that, I think there are a couple of things in terms of the integrity and validity of the data. We need to make sure that we are feeding in good data for AI to be a major force in terms of the decision making. But there's another major lens and element that will drive AI impact, and that is AI at the edge, or AI decision making at the source point of the collection of that data. The closer we can get to the source of that data, the more effective AI can be in real-time decision-making or near real-time decision-making. And from a sustainability lens perspective, that has a huge potential for impact. If we can make decisions in our natural world for things that are occurring that need urgent attention, and we can do it at the edge, and this is the intersection with IoT as well. If the sensor data can be processed, computed, using AI methods and mechanisms at the edge, and decisions can be made then in real time to affect the outcome and impact, rather than a legacy or long-time trend-based approach, then I think, again, we can have significant impact in environments that need urgent attention, rather than wait for time to affect that change.
Thanks, Kruv. And that really hits home for me with a conservation background. And when Yun was just talking about the studies that you do on streams and lakes as well, it's like, back in the day, you would go and do like your measurement plots and everything. You're out there in the field, but it takes a lot of time to get that data back out of the lab into the reports and just looking at the long-term trends, I guess. So it's really exciting to see the advancements in terms of like sensors and getting those real-time data as well. So yeah, awesome. Any other contributions to this question? Yep. So the next question is, how would you assess the general understanding of the impact of using AI? How transparent is this impact in the AI community, consumers, and policymakers?
I'm happy to kick off a discussion. I think, we have been biased or skewed around what OpenAI has done with ChatGPT, what Google's doing with Gemini, what Meta's doing with Llama, and there's a whole range of other LLM and GPT models out there that have pulled us in terms of, wow, this is really cool, and there's so much activity. I think we have to look at the word of bias around the impact of AI. We have to look at the types of data that are being used to train these systems. And I think going forward, the transparency around that, and I think there's a lot of deliberation, a lot of discussion post to OpenAI, post to Google, post to anybody who's developing these new AI tools around the training of the LLMs, and where is the data coming from, and what integrity checks have been put against those data sets. And so from a policy, from a regulation perspective, and we don't want it to be heavy-handed, we want it to be equitable in terms of encouraging innovation and not stifling it. But to the AI community and the ecosystem, to consumers, and most importantly to policymakers, what do we need to do to ensure that, particularly on the data side, that we have the right integrity, validity, bias checks in place? Because once we reach that point of AI outcomes, then, as we know, we're trending towards believing what AI systems output. And if we don't ask questions around how that AI is being trained, then we're getting into a societal dynamic that could be quite dangerous in some aspects.
Absolutely. Tracy?
Just from a kind of within industry point of view, I see two swings in the general understanding of the impact of using AI. So I see people within my workplace using it by stealth, i.e. not really sharing that with their leaders, and others who are not using it at all because of fear or not believing that there's any value in using it. And for me, it kind of comes down to the organization not putting in place policy around the use of AI and really sharing information around the benefits of using it, but also the protocols around what to share and what not to share. And I think that's why you get this swing of different users either doing it in secret or not doing it at all. And it does take me back to around about year 2000 when I started in the workplace, and I was provided an email and an email address, and I was specifically told by my manager not to email anybody. And I thought to myself, well, this seems like a really good tool, but don't use it. And it's a similar principle for me. We have this amazing tool, we just have to use it in the right way. And I think it's important for us to understand it and to understand the impact of it.
Thank you, Tracy. Yun.
Yeah, I think I will circle back to what Kriv has talked about in terms of transparency and what data is coming out, what data is going into these models and how reliable are they. To make a point about this, we might not be able to know what data goes in, but we definitely can give feedback. For example, part of it is if you were using something like OpenAI's ChatGPT, there is a little box that you can actually click to report something if you see that something is wrong. I think that this type of process is what we call red teaming, and to actually make technology a bit better, I think it needs a little bit of focus from the community as well, in terms of telling the companies that are making these AI systems that they might not be doing the right things if there is something that they see, or complaining about things to get things fixed, basically. These feedback is actually critical. It is about being heard and having a voice in this kind of situation.
Awesome, thank you. What are your thoughts? Like, how is this influencing, research in large research organizations, such as large universities, or, what are your thoughts on that?
Personally, in my opinion, part of it is this is all built into assessments, basically. When we do research, especially research in AI, there is guidelines that we follow. There's peer review processes that we follow. A lot of it is the assessment there is a kind of a protocol that we follow to ensure that we are doing the right thing. So the research community itself has come up with guidelines of different experiments that we do to ensure that what we put out there it's not a box ticking exercise, but more of like, are we meeting the requirements, basically? So there are some guidelines that we follow at the moment.
Awesome, thank you. Chris?
Yeah, I just want to add something Josh said earlier, and this is particularly when it comes to AI. If we can't measure, we can't really act, and we can't drive action. And I think in terms of impact, one of the things that we're probably not that good at the moment is being able to measure the effectiveness of AI. And comes back to Yoon's point around how are we fact checking? How are we measuring verification? How are we measuring validity of outcomes? And what mechanisms do we have in place? And does it need to be a community crowd? Does it need to be a more decentralized, distributed mechanism to ensure the integrity of these AI systems and not leave it to centralized large organizations to drive this? And I think as we move and evaluate other types of models like decentralized or distributed models, then we can evaluate elements around how more centralized models, like maybe, what's driving current LLM and GPT creation, and how these other methods around verification, around validation, around measuring impact outcomes can be put in place. So that is a community moving forward. We all have a say in terms of not just the validity, but the impact of the outcomes from these AI models.
Awesome, thanks, Kruv. Just on that, are you seeing a difference between the global community versus the community in New Zealand? Is there a difference, or are we kind of on par with how the world is kind of reacting to this?
Yeah, I think New Zealand and globally, we're still just in that initial phase of being wowed by generative AI. We're going, what is this? Where did it come from? How did we advance so quickly? So we're taking it in as for good at the moment, that we can use these tools and this knowledge to help us do things more effectively, drive productivity, drive better information, drive better knowledge. But I think that crowd, that community decisions around bias, around data source, around what's going into this, around centralized control, are starting to filter into the conversations. And I think both locally here in New Zealand, I'm starting to see through the IoT Alliance and through the AI Forum New Zealand, I'm starting to see more of those conversations happening. And I think globally as well, as being good AI citizens for the future of humanity, I think it's a really important balance that we need to strike in terms of the good that AI can do, but also the potential harm.
Awesome, thank you. Moving on to the next question. So looking ahead, what does your ideal intersection of AI and sustainability look like? What proactive measures should be taken right now to reach that future? Josh?
You to it, Krev. Yeah, look, I think it's specifically, again, talking to what we're trying to achieve. And again, I do believe in the work that we're trying to do is empower people with the data that exists to help make their decisions better. And I think we have a part to play in that, which is really exciting. But the ability, regulation, for example, is coming it is here for enterprises in Aotearoa to measure their supply chain. And when you're looking at scope 3, which is supplier emissions, category 1 is spend on goods and services. And so when they're buying from a small business, take a large corporate buying from a small business, they need to know the emissions of that small business. And it is a very convoluted, long, expensive process currently. And to get a small business to give you that number takes a lot of time. And so again, with the ability of what we're doing is basically using machine learning to auto-categorize transactions and come up with that number in a matter of minutes. So I think the ability to measure is there. I think everyone needs to know that number, as Krev and I have both said. Once you've measured it, it gets managed, and then the management. We believe that sort of AI within personal banking and personalizing that experience to help people and businesses, either in accounting or banking experiences, to spend better and to lessen the impact. It has a significant opportunity and a significant impact associated to that. I reflect again back on the trillions of dollars that we need. The money is coming. These banks are putting up astronomical amounts of money. Just look at the New Zealand banks, but we're working with Standard Chartered Bank. They've got $100 billion that they're putting to decarbonize their customers globally. So the money is coming, and it just needs to be streamlined to those that need it, and it needs to be done in a credible and fast fashion. But I think we're excited by the ultra personalization and the speed in which we can get people to understand what they need to do, motivate them to do it, and provide them the finance and funding to do it. So, for us, I think starting now, what should happen is, again, that sort of legislation and understanding of the commercial opportunity, and then things will start accelerating at pace. I agree with what Kriv just said, that everyone's still trying to figure it out. But we, talking to banks, they have significant AI budgets right now. Whether they put them in the right place, they have the money to spend on these ideas. So if the right ideas are coming along, they're investing in them. So yeah, I think for us specifically in our sector, a significant opportunity for global decarbonisation through the use of AI in banking and finance, for sure.
Awesome. Thanks, Josh. Kriv?
In terms of my ideal intersection, I see it at a scale point. And so at a very nano scale, where can AI be applied to sustainability and the natural world and the environment? It's things that humans can't sense and see. And what can we do in terms of decision making at a very, very small scale across all types of environmental issues? And then as we move through that scale point at a massive macro scale, as Yun mentioned as well, if you're using space data, if you're using low Earth orbit space data at a massive macro scale to do large scale trend analysis, large scale forecasting of our waterways or pollutions levels across our natural environment, then what does that look like? So I think the scale of AI being applied all the way through the granularity, right from a massive micro or nano scale all the way to a massive macro scale, to something that's very hyper localized and hyper personalized to a small scale, to something that's not just global, but moving into space, and the view that space can give us from an AI compute decision-making power on terrestrial and Earth outcomes as well, gives us the ability to affect change at a different continuum or different granularity. So I'm really interested in that intersection of scale and what we can do to join those data points from that nanoscale to that massive macro scale.
Fantastic, thank you. You and I was also thinking that perhaps we need to add 2 more M's to the model. Measure and manage is what I'm hearing. But can I hand over to you just to answer this question?
Yeah, I think I'm very much an idealistic person. So I always think that if we can actually look at AI and what it brings right now versus what it would look like in an ideal world, I think AI, we can use AI as what we call an environmental guardian. It helps us to be a little bit more productive in how we're managing resources and managing our sustainability measures as well. I think part of that, allowing us to actually have things like green infrastructure, things that have different building technology with different materials that's more sustainable as well. On the other side of things, I think if we can actually make it more transparent in terms of how things are looking like and how AI is built, that might help uptake as well. And I always think, what are proactive measures that we can use right now? And I'm putting my other hat on, which is I am actually the program director of Masters of AI here. One thing is education. Education is one of the things that, and awareness is one of the things that will help in this, and being able to promote what is the environmental impact of AI and how do we promote responsible development of AI as well. So that's part of it as well in the question, sort of answering this, I guess.
Awesome, thank you so much, Yun. Tracy.
Yeah, just a quick one for me in terms of speed. And one of the greatest benefits from my point of view of AI is speed and speeding things up. We all know, how how much more efficient we've become by using AI. One of the architects at my work has reduced his work from 2 weeks to a few hours. Was able to create lots of different scenarios to show low carbon buildings within a few hours, which would have taken him 2 weeks to do. And that's one of the big benefits for me is how can we speed things up to make us more sustainable? Because there's no doubt that, we're running out of time with this stuff. So let's get AI to work for us. And I think, like Young said, you know, a bit of a guider, a recommender. That's the way that I see it. Someone that, or AI to recommend the best approaches to us based on volume of data, volume of information, which previously, I guess, as human beings, we can't, you know, absorb as much as AI can in terms of volume of data. So that speed and the volume is quite an important thing.
Awesome. Thank you, Tracy. So we're just moving into the section where we open the floor for any questions from the audience to our panelists. I see, Chris, you have a question here. I have seen AI commonly used for analysis of large historic or current data sets and content generation. What are the specifics on how AI can support actual actions? What is the role of AI beyond suggesting this is a good thing you can do? I see, Josh, you've tackled that one in the chat. Did you want to maybe speak to that?
Yeah, sure. I just responded in regards to how we look at that, and it's a really good question. How do we actually look at that? So in regards to using a machine to learn based on the data, what a similar person or business that looks like you based on your emissions profile, where you are, your salary, these types of things. Recommending actions to someone is only relevant based on it needs to be reflective of the systems by which they reside under. You know, we can't get everyone to take public transport if those options aren't available to them. You know, solar panels for someone that lives in an apartment is not a suitable solution. You know, obviously renters and these things you can see if rent is going out, if your money's going to Harcourts once a week, once a month, we know that you're a renter, and these are some things that we should exclude. So, you know, in Kogo's version of this, we refer to it as the next best action. What is the next best action recommended to that individual or business based on someone else that looks like them? So it's not just providing that action, but it's also understanding when you have provided that action to a business or an individual previously, have they actually been able to reduce emissions? So it's actually need to be attainable. These need to be climate actions that aren't just recommended, they need to be attainable. So we do a lot of mapping there in regards to this is what this person or business looks like. Here's some individuals or businesses that look like them based on a range of different factors. And then have they been able to actually reduce emissions? And then we provide those actions to those businesses or individuals. So yeah, that's our take on it, Chris.
And just to add to that, Josh, I think AI is definitely not a silo technology, and we can't look at AI in a vacuum. It's part of a systems-based approach when it comes to new emerging disruptive exponential technology adoption. And I think one of the main things when we have a look at AI driving insights is what are the action technologies that aligned to those insights that AI is deriving. Technologies like robotics, technologies like the creation of design tools and digital twins, and so, or 3D printing. So what are those action technologies that can really be leveraged to use the insights from AI to action things back into the real world or in the digital realm as well? And I think those interfaces and that interaction between these action technologies and technologies that AI might direct is really important. And I don't think we've got that yet. Yes, AI is being used a lot in robotics at the moment. The other point that I just want to touch on is in the area of IoT, one of the first things that sort of came out is industrial IoT aligned to Industry 4.0, or the part of where industrialization and IoT and sensors intersect. And I think the same thing resides with AI. What is that intersection now with Industry 4.0 and AI? Where does manufacturing, where does precision manufacturing, precision agriculture, where does that base intersect with AI? And what are the action technologies that are being used to drive changes in those environments that AI can help direct? And I think we're at the cusp of it. There's a lot of pilots and prototypes and even some really good early commercial models, but we need to continue to bring the directedness that AI is bringing from an insight perspective much closer to the action technologies that are also evolving at a fast pace.
Awesome. Thank you, Crow. Any other thoughts on this? Oh, and there's another question from Nadia. The flip side is AI is likely to further drive consumption via marketing effectiveness tools. I'm curious to know what proactive measures should be taken now to protect consumers' attention and wallets. You've made some comments there too, Josh, and I think this leans into the conversation that we had as well. Yeah, do you want to make a comment on that?
Yeah, happy to. Yeah, I think maybe Kriv and Yun could talk to the regulation side of things, but I think regulation is slowly starting to creep out into this space, and I think it is definitely one way of controlling marketers and large retailers from controlling AI to affect consumers. The argument could be how long has versions of machine learning been doing this for a while, regardless. So yeah, we're probably a little bit behind on that. I think the other side I would say is that a lot of these big industries, and again I know a lot about banking and finance, that's sort of where I reside, but the commercial opportunities to help them understand the decarbonisation opportunity and clipping the ticket on supporting consumers to decarbonise. I think there needs to be and has to be, hopefully will be, significant spending in this space going forward. And so those industries that get behind that can really help. So yeah, for me, I think regulation and commercial opportunities are the two big ones there.
Right.
I think the other element here, Nadia, it's a really good question. I think it's the embedding of AI agents across all of our e-commerce and social media platforms. I just went onto Facebook yesterday and saw how much they've embedded Meta AI into all of Facebook. You've now got an AI agent that is sort of watching what's being said to aid you in creating better social media and social network experience. But it's leveraging a lot of data, and that data will definitely show up in some way, shape, or form from a marketing perspective. So the embedding of these AI agents needs to be transparent. There needs to be transparency around how deep these AI agents are being embedded into the social networking, social media, our consumer e-commerce platforms. And if it's not transparent, then I think we are getting into that area of regulation and policy. I don't like it to be heavy-handed, but there does need to be some protection mechanisms around the embedding of these AIs without our knowledge.
Thank you, Crow. So another question from Nadia. How could AI streamline ESG reporting processes and reduce the complexity involved with adhering to various third-party standards and certifications for businesses? And Josh, this falls in your field.
Yeah. Sorry to keep jumping in first, team. I'll quickly touch on this, and I'm happy to have a conversation with you specifically, Nadia, if you want to email me as well. I think regulation is sort of two pieces right now. One is that supply chain emissions reporting. So large businesses need to know their emissions of those businesses. Those businesses need to create their number, and that's again, what our tool and other tools can do is they can generate that number very quickly for that small business to pass on to that organization. Another one is financed emissions. So banks need to understand all of their financed emissions. There's a range within that. One thing that'll be relevant for the group is understanding mortgage customers. So if a bank gives you a mortgage, they own a part of your house. They need to know the emissions of your house. So again, they need that number and sort of making that very easy for that household to give that number, or for the bank to attain that number. Right now, they do it based on sort of square meterage of a house. What Kogo sort of can do is provide an energy emissions. So it's a bit more accurate. And again, it's sort of pulling through your spend data, identifying energy spend, and then passing that number over to the bank as well. So again, those are sort of two areas that we can really push that forward. Certification, I think, is a really interesting one. I've already touched on us being a certification with Toitu. Our viewpoint is that certification is not going to solve the climate crisis. We need to decarbonize, and charging small to medium businesses a lot of money to go through this process to very crudely get a stamp of recognition is not actually solving the problem. So we need to focus on decarbonisation solutions. And so yeah, I agree with the reporting. That's going to help. But I think certification is not the answer. Decarbonisation is. But yeah, we can probably talk that in private if you want, Nadia. No problem.
Thanks, Josh. This might be the last question that we take from the floor, just mindful of time, but it's from Chris. My limited understanding of AI machine learning is that it looks at current or historical data analysis and can predict model future outcomes. Can it cope with disruption? What about future predictions when social or environmental paradigms might be radically different, e.g. extreme weather events or net zero economy or policy? Yun, I feel like this is kind of in your remit.
Yeah, I think this is a very interesting question because this is a specific area of AI. We call it concept drift, which means that there is a shift in modality or shift in the distribution of data, as we call it. So a lot of the times when, for example, during COVID, the production sector or the pipeline for production, there was a shift. And how did AI models deal with it? I would say badly at that time. People sort of learned how to actually deal with these kind of issues now, have a little bit more of an understanding of, yes, when the data is no longer representative of the current situation, the AI system might not give you the best predictions, but there is a lot of guardrails around it that I think industries would put in place to actually ensure that they're constantly updating the models or retraining the models when it is out of sync. When we talk about extreme weather event, I would say that's a very different kettle of fish. Extreme events, because the climate's constantly changing, extreme events are really hard to predict. In parts, it's because that the data we have, AI models are very good at predicting on average. So when we talk about extreme events, things aren't actually seen as much. A lot of the researchers currently are trying to actually deal with this. So that's part of the issues as well. But we're getting better, and AI is actually definitely getting better. And one point that I want to actually point out in terms of sustainability in AI is that there is what we call regional climate models, which is physics-based, and those are really, really expensive to run. Physics-based models cost around $30 to $15 million to run. Whereas an AI-driven regional climate model could cost anywhere between 30 to 100,000 only. So the scale is very different for environment.
Thank you, Yun. Any other contributions to that question, Kurt?
Yeah, in terms of historical data, generative AI right now has been traditionally trained on older data sets. But as we get closer to more real-time or near real-time training of data, then the contextual awareness of that AI becomes, again, much more accurate. And so in terms of looking at a shorter time horizon, using more real-time, near real-time data, I think we're about to hit that inflection point with AI. So the closer we get to data that was trained minutes ago or hours ago rather than years ago, the better we'll get in terms of that prediction and forecast capability for near real-time or even longer time events. And so, but the downside of that is we're going to need massive compute power if we're training with real-time data as an ingress point, and the amount of data. And if I correlate IoT sensors collecting billions and billions of data points every second globally, and if we feed all of those data points in real time to training a more contextually aware real-time AI, that's going to require a significant amount of compute power and energy to go to. Yes, there's benefit in terms of the accuracy of our prediction and forecast models going forward, but the downside from a sustainability perspective is it's going to change how we power these systems. So yes, a balanced perspective is needed, as we started with, and from an AI for sustainability, I think there are a lot of organizations and innovation houses that are looking at to solve this problem.
Awesome. I think that was a beautiful way to conclude the session, actually. So thank you so much, Kriv. And thank you to everybody who posted their questions in the chat. So what's next? So we have our experience challenge next. That's in May. And so Kriv and I are going to put our heads together and create a challenge for you based on, you have the knowledge now from this session, and hopefully you go away, do a bit more research, you know, find out more, and we'll help you with that as well. I'll share the recording and the insights that was generated from this session. So it's on the 8th of May. It's afternoon. It's over wine and cheese. It's very relaxing, and you know, that's the setting that we're aiming for. We'll have a challenge for you. You'll get into groups and, you know, actually ideate and solutionize and pitch. And there are prizes up for grabs for best solution that a group comes up with. So I'm really looking forward to seeing many of you on the call today at our challenge session that's in May. And so, yeah, thank you, everybody. And thank you so much to our panelists for joining and sharing your knowledge so freely. I hope you got a lot out of this session as well. And thank you to everyone who joined the call. You know, again, I'm looking forward to seeing you all on the 8th of May as well. So I'll just close this space with a karakia. Ka wakahiria ti tapu, kia waiti ai te ara, kia turuki whakatahi ai, kia turuki whakatahi ai, homie huie tai kie. Kia ora, everybody.